Good day once again. You're welcome to another edition of Uncle Chemist's channel. Today I will be giving you a brief explanation of what Charles' law and Boyle's law is all about. Let's start with Boyle's law. Boyle's law states that the volume of a fixed mass of gas is inversely proportional to the pressure, provided the temperature remains constant. What is the meaning of inversely proportional? When we are dealing with two terms or parameters in science, let's take for instance, in this case, we are dealing with volume and pressure, but they are inversely proportional to each other. It simply means when volume is increasing, pressure will be decreasing. When volume is decreasing, pressure will be increasing. This explains that these two terms are inversely proportional to each other. So that's what Boyle's law states. The volume of a fixed mass of gas is inversely proportional to the pressure, provided the temperature remains constant. Now we can use this with an illustration to make you understand what Boyle's law is all about. Let's take for instance, you have a balloon right here. Now when you look at the volume of this balloon, it may have a volume of about 10 cm3. Now, when we apply a little pressure on this balloon, we will observe that it will decrease in size as a result of the pressure acting on it. Now, let's take for instance, the volume was 10 cm3 when the pressure acting on it is 200 millimeter mercury. Now, what will be the new volume if we increase the pressure with more muscles on the body of the balloon? Will the volume increase or it will decrease? I think you already know what the answer is. The volume will decrease. Now that is because the pressure has increased, making the volume to decrease. Now this explains what Boyle's law is all about. The volume of a fixed mass of gas is inversely proportional to the pressure, provided the temperature remains constant. When there is an increase in pressure, there will be a decrease in volume. Next, we will be talking about Charles' law. Charles' law is dealing with two major parameters, and they are volume and temperature. But do not forget, the temperature must be in Kelvin. It means when your question is given to you, and you realize that the temperature is measured or is given in degrees Celsius, do not forget, you have to convert the degrees Celsius into Kelvin. How do I convert degrees Celsius into Kelvin? Simple. All you have to do is to sum it up with 273. Let's take for instance, 10 degrees Celsius. What will be the value in Kelvin? So we do 10 plus 273, and my answer is 283 Kelvin. Simple, just like a piece of cake. Now what is Charles' law saying? When the temperature is increasing, the volume will increase, because the volume is directly proportional to the temperature. I repeat, Charles' law states that the volume of a fixed mass of gas is directly proportional to the temperature in Kelvin, provided the pressure remains constant. Now let me use this example as a practical illustration of how we can actually apply Charles' law in our everyday life. I was playing a tennis ball with my friend one day, and the tennis ball landed on the ground. Then one of my friends mistakenly stepped on it, and then I picked my tennis ball. What I observed is that the volume of the tennis ball has decreased, and I was not really feeling good about it. But what do you think I need to do? I remembered the application of Charles' law, and what I did was to get the tennis ball, and I rushed into the room and placed it in a boiling water. And what happened? All of a sudden, the volume of the tennis ball increased again. Why did that happen? Take a time to think about it. It is simple. This is because when we stepped on the tennis ball, the volume has decreased. at this temperature. Now, I hurriedly carried my tennis ball into a boiling water that has a very high temperature. And what happens to the tennis ball? It increased. This proves that Charles' law is valid. And what does that mean? The volume of a fixed mass of gas is directly proportional to the temperature in Kelvin, provided the pressure remains constant. I believe with these few words of mine, I've been able to educate and elucidate you more about Boyle's law and Charles' law. Join me as I progress into the other gas law and equations to make this topic simple for every one of us. Do not forget to give me a big thumb up and follow me on my channel, Uncle Chemist. Love you guys.